Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 4, Chemical Foundations, Part 4. We're going to be talking about precision and accuracy, random and systematic error, as well as getting started on simple unit conversions during today's video. Pause here. You do not need to draw the picture unless you would like to. So when we are doing experiments together, we're going to need to describe our data as either being precise or accurate, or one or both of them. So precision describes how close measurements are to one another. Another way you can think about precision is how many decimal places that there are in a measurement, but that has nothing to do with what the true value is. Whereas accuracy is the proximity of measurements to the true value. So the image all the way to the left, it's highly accurate because everything's near the bullseye, and highly precise because they're close to one another. This second one, we've got low accuracy. They're not centered around the bullseye, but they're high precision because they're close together. The third one, we've got high accuracy. On average, they're near the bullseye, but low precision because they're not close to one another. And then our fourth one, low accuracy, low precision. They're all over the place, and they're not centered around the true value. Pause here. I'm going to wait about 10 seconds, and then I will say the answer out loud. So student C is the most accurate because his or her measurements are closest to the true value, 2.000 grams. Student C is also the most precise because his or her values are closer to one another. They're 0.002 grams away from one another. The other ones are a little bit further apart. Pause here. So there's two different types of errors, and I just want to clarify that errors and mistakes are not the same thing. You can prevent mistakes. Mistakes are when you do the wrong thing, whereas errors are not always going to be preventable. So random error describes natural fluctuation in measurements, and this usually will cause lack of precision, is usually going to come from random error. So for example, if you step on the scale in the morning and, for example, it says 150 pounds, and then you step off of it and step back onto it, and then it says 149 pounds, chances are you didn't lose a pound. That's just random error. That also comes from the fact that the user, or sometimes the electronic tool, is estimating the uncertain digit, that last digit. The second type of error, this is something we really want to prevent, is systematic error, which describes a fundamental flaw in the way that a measurement is carried out, usually a miscalibration, and that's going to cause lack of accuracy. So for example, if somebody who is 150 pounds steps on a scale and 3 times, and each time it says 95 pounds, that is systematic error. That scale is miscalibrated. Pause here. Right, so we're going to be moving on a little bit from random systematic error into dimensional analysis, and this they will all come together when we do experiments with this. Dimensional analysis is just a fancy word for a unit conversion. We're going to be using unit factors. I should have given you guys a sheet in class of unit factors. If not, let me know, and I will upload one to Classroom. And these you can treat as constants. So 12 inches over 1 foot, 1 foot over 12 inches. These are just fractions that equate to things that are equal to one another. And you can use an infinite number of unit factors to complete between units. So if you need 95 of them, you can. The important thing here is that you make sure that your units cancel out. Pause here. I'm going to work through this with you so you can see how this works. So you don't have to put the first part of it in a fraction form. I'm going to for the video so you can see how things cancel out. All right, so I go to my sheet of unit factors, and I see that 1 inch is equal to 2.54 centimeters. So I put 2.54 centimeters up at the top, and I put 1 inch at the bottom. The reason why is because I want inches to cancel out. Then I just go ahead and I do my multiplication, and then I'm going to round to 2 significant figures. You're always going to round to the number of significant figures that you start with here. We'll talk about variations of that later on. So 63 inches, that's about my height, is 160 centimeters. I did not include the dot because I wanted to have 2 significant figures. Pause here. I'll work through this one as well. So I'm not going to put it in fraction form this time, but it's up to you whether you do or not. So I'm going to use the unit factors that I gave in the sheet. Obviously, some of these you'll have memorized, so you could do this a little bit simpler if you wanted to, but I'm going to do it the most complex way, just so you've seen it. So cancel seconds with seconds. I cancel out hours with minutes. Then all I do is I put this in my calculator and I round to two significant figures. This is going to be a whole lot easier with a graphing calculator. That's why I suggest them. Then to round that to two sig figs, I'm going to make that 150 years. I originally got 145.86504. If you use slightly different unit factors, you might get a slightly different answer. That's usually not an issue. And if you did get a different answer than me, just please let me know. We can figure out what's going on in the calculator. All right, thank you so much for watching and have a great night.